So the next question is based on trigonometric equations. So P is equal to theta from 0 to pi such that tan square theta is not equal to 1. These are the conditions that are to be satisfied. Tan square theta not equal to 1 and 2 times cos power 8 minus sin power 8 into secant 2 theta is equal to a square, where a is an integer. That means this LHS has to be a perfect square. So for how many thetas in 0 to 4 pi, the LHS is a perfect square? That's the question. So let us try to see what this is. So 2 times, so we know that cos power 8 minus sin power 8 can be written as cos power 4 theta minus sin power 4 theta into cos power 4 theta plus sin power 4 theta into secant 2 theta can be written as by cos 2 theta. So now this cos power 4 minus sin power 4 can be written as cos square theta minus sin square theta into cos square theta plus sin square theta. So cos square theta plus sin square theta is equal to 1, and this cos square theta minus sin square theta is same as cos 2 theta, both are getting cancelled. So this is nothing but 2 times cos power 4 theta plus sin power 4 theta. So this trigonometric expression can be further simplified into 2 times cos square theta plus sin square theta whole square minus 2 sin square theta cos square theta, which is equal to 2 times 1 minus 2 sin square theta cos square theta can be written as sin square 2 theta by 2. So simplifying, this is nothing but 2 minus sin square 2 theta. Now according to the question, this has to be a perfect square. Okay, so clearly 2 minus sin square theta belongs to sin square theta range is 0 to 1. So this belongs to 2 to 1. The range is 1 to 2. And this has to be a perfect square. These are the form integer square. So between 1 and 2, what are the integer squares? There is only one number. So this implies 2 minus sin square 2 theta has to be equal to 1, which implies sin square 2 theta is equal to 1, which implies 2 theta is equal to n pi plus or minus pi by 4. That's the general solution. Sin square something is equal to sin square something, which implies theta is equal to n pi by 2 plus or minus pi by 4. So for this there are lots of solutions. That means if you take the quadrant diagram, there are 4 positions of the ray which satisfies this equation. But for all these 4 positions, you can see that tan square theta will be equal to 1. Pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. For all the 4 values, tan square theta equal to 1. But according to our question, tan square theta should not be equal to 1. So the number of elements in the set P becomes 0. There are no elements which satisfies both the conditions. So the answer is 0. So I hope you have understood this question.